Okay, well, it's 4 o'clock, so I'm going to get started. Hi, everybody, and welcome. And my name is Donnie Roisman. I work for a company called Peak Web Consulting. I'm going to talk to you about effective BGP load balancing using the metric system. So this is a real-world guide to BGP traffic engineering, stuff that we've used, worked in multiple situations, been using this technique for a very long time. Peak Web Consulting, we do network engineering, we do design, we'll do deployments. We help a lot of content companies that don't have their own in-house network engineering staff, simply because they don't need enough day-to-day networking. And they'll bring us in when they're growing and they realize they need more sophisticated networking, multi-homing, grow from 1 rack to 20 racks. They want to get all the redundancy resilience. And thanks again to any program committee guys that are out here for giving me another chance to come up here. I really appreciate it. What is BGP load balancing? So networks that have multiple ISP connections and receiving the full routing table via BGP, typically you're multi-home. So you're connecting to diverse ISPs. Some cases it may be 2 links to the same ISP and you're trying to load balance across them. You need to balance the utilization of all of these links. Maybe they're mismatched, 1 gigi versus 10 gigi, OC48, OC3s. Typically you need to balance in order to control your cost. Maybe you have a 500 meg commit on one link and a 300 meg commit on the other link. You don't want to be sending 800 meg to one ISP and 0 meg to the other ISP because you're paying for bandwidth you're not utilizing. And of course, you're also going to balance your traffic in order to avoid congestion. Again, if you have a 1 gig link to one ISP and a 10 gig to the other, it doesn't make sense for you to be sending 900 meg on the gigi link and 300 meg on the 10 gigi link. So you're going to have to shift traffic around. Different reasons you may balance traffic. I'm going to be talking primarily about outbound traffic here. There are different techniques for inbound versus outbound BGP. And typically for content networks, which is where I end up doing most of my work for the past 10 years, outbound is the larger amount of traffic, the higher volume of traffic, and it's where you're paying for your money. And conveniently, that's actually where we have more control. So we get to be very successful there. This technique we're talking about is, I got a floating hand on my screen. That's kind of cool. The technique that we're talking about are usually, we usually apply these towards ISP uplinks specifically. These are transit ISPs that are sending you a full table. If you have peering as well, peering, you're going to typically pretty much prefer whatever they're going to tell you you can send to them. So not talking that much about how to balance across your multiple peering links. Inbound balancing, as I said, is different. It's less precise. Many times you're not in full control of your inbound, not nearly as well as your outbound, and the inbound traffic also relies upon behavior of your ISP or even 3-4 hops down the line as far as other decisions that people will make. So what's the problem here? Why am I giving this talk? So there is no standard method of balancing traffic over multiple links. We also call it BGP traffic engineering. You can't just buy a book that says how to balance BGP and there's one way that everybody does it. There also is no routing language where you can just type in conft int gigi 0, I want to send 500 meg to this ISP, int gigi 1, I want to send 300 meg to that ISP. It doesn't exist. There isn't a standard routing protocol that is. There are some hardware software solutions that will do route optimization, that will give you utilization balance as well, will give you cost control. Some of them they may be incompatible with your physical network layout, your topology, because a lot of them require promiscuous sniffing of traffic. They may be out of your budget. Historically, some of that hardware can cost in upwards of hundreds of thousands of dollars and may be difficult for you to cost justify. And I found there are so many guides that introduce BGP, that tell you about BGP. They tell you about attributes, they tell you about route balancing, preference decision-making process, but they only seem to really touch upon how to effectively control the traffic control the balancing of traffic. So that's what I'm hoping to share. So who's going to be interested in this talk? Mostly, honestly, enterprise or content networks that have diverse uplinks to their ISPs. Regional transit providers, maybe the smaller ISPs that have diverse upstream connectivity in their regions. BGP novices, those of you that are just learning about BGP. Senior network engineers who want to train junior level staff and want to have some material they can use. You feel free to download my presentation, use the diagrams. Ask me if you think you want me to change them around for you. the target audience for this kind of talk seems to be increasing. More and more end-user networks are actually multi-homing. It's less expensive. It's easier to multi-home. Thanks to all the carrier-dense facilities, it's very simple to land in one of the carrier-dense facilities and pull GigE to 3 or 4 ISPs without too much excessive cost. Layer 3 switches now are taking full routing tables, so you're not paying the kind of port fees you used to pay back in the OCX world. And more content networks that are really relying upon their businesses being up 24/7 are realizing they can no longer just buy from one ISP and always have their stuff up. Every ISP has problems, and by diversifying your transit, you can increase your uptime. So what are you going to learn today? You're going to learn a BGP load balancing method that I've personally used for over 10 years. It's consistent, deterministic, effective. At PeakWeb Consulting, we've applied it at over 10 networks successfully, and of any sizes, ranging anywhere from 10 megabit per second peak traffic all the way to over 80 gigabit per second of peak traffic. Same exact technique applied, works very, very well. We're going to use a sample reference. I'm going to use a sample reference over and over again, so I just wanted to walk you through briefly. Down here at the bottom, this is your content network. This is where you're working, your domain of control. And you're buying from 3 ASNs, AS1, 2, and 3. Your AS1 and 2, let's call them a tier 1 or a transit-free, a fully peered network. They have a full routing table. They can get to a lot of the network with maybe 1 or 2 hops away. Your AS3 in this case is more of a lower tier network, a tier 2 or tier 3. He's mostly buying transit from one ISP, maybe a few peers as well, and majority of his traffic will end up going 1 more hop above. In our base configuration, we have 2 border routers. You might call them edge routers. I call them border routers in your network. They have iBGP between them. Border 1 has eBGP with 1 ISP, and border 2 has eBGP with 2 ISPs. So altogether, you're very wonderfully multi-homed. You have wonderful diversity, no single point of failure. You're doing great. Now you got to do something with that network you built. Let me give you a brief refresher. Again, this may be for more of the BGP novices, maybe some folks that haven't touched BGP in a while. Maybe material if people want to heckle me later, but I'm pretty confident what we're talking about here. The BGP routing decision is made based on lots of different pieces of information that get carried with a prefix. Different vendors will have slightly different decision makings, slightly different steps in a couple of these decisions. The 3 that I'm focusing on are pretty universal. So typically a prefix, which decisions made on a prefix, a router might compare weight between multiple multiple options, BGP local pref, AS path length, an origin code, a MED, what's going to call this the BGP metric, how the route was learned, was it EGP versus iBGP, the metric, IGP metric to the endpoint, do I have to cross the country before I hit that ISP, or is it in the same city as I am? The oldest route entry, I heard this route 3 days ago, and I just heard this route right now. If the route better, equal, am I going to keep the old route, install the new route? And a couple of tiebreakers at the bottom, the actual IP address of the BGP neighbor IP, or the actual IP address of the BGP neighbor next hop. This is the general sequence in which attributes are compared before a best route decision can be made. As an example here, simplify the network here. You have 1 border router. You have 2 possible paths to 10.0.6.0, who's coming off AS6. You pretty much have going out AS2. You'll make a hop from AS2 to AS4, from AS4 to AS6. That's 246. From AS3, you'll make a hop to AS5 to AS6. That's AS path 356. Setting all things being equal and using mostly default values, your metrics in some cases will usually be 0 if you don't touch them. Depending on your ISP, your local pref default 100, your origin type IGP. You see here we have 2 equal paths. We need to make a decision, of course. This is the way this would look on a Cisco router if you're doing a show IP BGP 10060. You'll see those two next hops, and there's your path, either 356 or 246. You'll see your local pref of 100, your BGP metric of 0, and your proprietary internal weight, also set to default value of 0. Slightly more verbose entry, pretty much the same thing, different way to look at it. In the Juniper world, the output is very simple, very similar, except for Juniper is using a more generic header. Metric 1 in the Juniper world is local pref. Metric 2 in the Juniper world is the MED, or the BGP metric. And same thing, you'll see your different next hops and your 3 AS hops, either 356 or 246 to get to that route. And below here is a more verbose version. You can download the slide if you want to read it. So this is what the routers are going to do. Border 2 over here, he's going to compare, well, what's my weight of preference? My weight of preference is, I'm not showing it here, it's 0. what's my local pref? My local pref is default 100. What's my AS path length? It's the same hop count, 3 hops. Well, which path is going to be selected? eBGP versus iBGP, they're both eBGP. The IGP metric doesn't apply because it's just the next hop. In most cases, the router ID and the next hop really only gets compared if the destination network is the same ASN. So in this case, depending on platform, it's usually going to go to oldest route first. Well, that's not deterministic. Let's say right now we're selecting path through AS3, because AS3 you turned up as BGP 3 weeks ago, and AS2 you turned up 2 weeks ago. So all your traffic is going at AS3, and you're a happy camper, and your balance is working great. And then tonight, AS3 has a maintenance, and they take the link down, BGP goes down, comes back up 30 minutes later. Well, you just shifted to AS2, and you're not going to go back to AS3, because now AS2 is the oldest heard route. So you might believe that you have your traffic balance, and then an ISP is going to perform a maintenance window, and your traffic balance is going to shift. Well, that's not good. I don't like it. You're not going to like it. Your boss isn't going to like it. And your NOC isn't going to like it. And you're not going to like it when you're getting woke up at 3 o'clock. So let's talk about these 3 attributes of interest. These are attributes that we use to tweak traffic using the system. So there's a local pref, which is the first one that is compared. This is set locally within the AS, and it's only shared between iBGP neighbors. I'm not talking about confederations here. It gets a little more complicated. I'm really going to stay sticking with the simple network design here. The AS path length, number of hops. So it describes which networks have to be traversed to reach the destination. AS3, AS4, AS6. It's shared with all BGP speakers across the internet. There's this thing called BGP origin code, which can have 3 possible values, interior, exterior, or unknown. It's only really interesting because it actually interferes with this metric system. We're going to actually disregard the attribute later on. We don't use it. It's not very widely used. I haven't found it to be reliable or meaningful. My apologies to the architects of BGP. And then here's where all the money is. It's called the MED. It used to be called the MED when it was created. I call the BGP metric. Many implementations called simply metric. This describes something that's called the cost to the destination. So it's a cost-based metric. Lower is better. It's shared both. It can be shared with eBGP and iBGP. Oftentimes, it really only has relevance within an AS because there isn't any standard. Some ISPs may calculate fiber kilometers. Some ISPs may calculate number of IGP hops. Some just may import the IGP into the BGP metric. And oftentimes, your ISPs will reset it to a fixed value, typically 0, before they send you a route. Or if they're not, we're going to actually reset it in our system here to make it worthwhile for us. Refresher again, a local pref default value is 100. It's a preference type, so the higher the number, the more is preferred. Often, it's the only traffic engineering that we're seeing in use. When I come into a network, typically it's the only knob that's used because it's simple, it's effective, people just throw it in, it just works. The problem I have is a heavy hammer. Decision based on the local pref ignores other route attributes such as AS path length, and I think AS path length is pretty valuable. I think that local pref should be used only as a last resort for where metrics don't do what you want them to do. And you're going to use it when you're going to do a hardship. You want to cost out all traffic out one link, just go ahead and slam it with a local pref of 5 so that you no longer send traffic out that link. An example of how we're seeing local pref being used. Let's say you want to send all traffic to 10.04 via AS3. Typically, 10.04 is actually shorter via AS1 or AS2. It's only 2 hops, 1.4 or 2.4. For whatever reason, you want to send all the traffic out AS3. Now, your easiest way is to set it higher than default local pref of 200, and that route will be selected, 3, 5, 4. AS path length, that attribute. As I said before, it's a count type. The lower the count, the better. Typically, less ASN hops means better performance. Do I need to go through 5 different ISPs to get to that end host, or 2 different ISPs? There are definitely less variables when you go through 5 ISPs. Now, this is really the only indicator that we have for route quality across the public internet. For better or for worse, I'm not saying it's perfect, but it's all we got. So I like to say, let's use it. We might as well take advantage of it. And now as a bonus, the other reason I like to listen to AS path length is that remote networks can send me hints on how not to send them traffic. I'm going to show you that in a moment here. Default AS path selection, shorter is better. Looking here at the path to 10.50, which is hanging out right over here. If we looked at our base network, we'd see 3 hops, 1, 4, 5, 2, 4, 5, or 2 hops, 3, 5. In this case, I'm going to choose the shorter path, 3, 5. And with less ISPs in the path, there's less chance of things that may go wrong. Congestion, peering congestion outages, conflicting maintenance windows, etc. Here's what I was talking about how a network can hint to me that they don't want to use a path that they may be multi-home to. So for example, 10.4.0 is coming off of AS4. They're multi-home to AS1 and 2. Maybe for cost reasons, maybe for congestion performance reasons, they don't want to use their link to AS2 as inbound. So what they're going to do is they're going to prepend their AS twice when they announce it to AS2 and not prepend it to AS1. So what happens for me as the content network down here, I see one path AS1, 4, 2 hops. I see another path AS2, 4, 4, 4. That's 3 hops over here. And AS3, 3, 5, 4. So normally I would have had an equal cost between AS1 and 2. By AS4 setting a prepend, they're hinting to me, I don't want you to use that path. Now if I had a local pref I was using to force that traffic on AS2, I would be sending it to AS4 on a less preferred path. I want to respect their request because usually they have a good reason. And if I was to shift it to AS2 with the local pref and not listen to AS hop count, I might be doing a detriment to my end users because I may be sending on a congested link. Talk about the med attribute. As I said again, the BGP metric attribute. By default, the value is 0. Or in fact, by default, the value is actually null. It's not set. As I said, it is a cost type, so the lower is the better. The med was called the multi-exit discriminator. So it was initially created to allow one ASN to tell another ASN how they prefer to receive traffic if they have two links between them. It was used to trigger what was called cold potato routing. And it was only by default consulted if your remote ASN, if you have 2 links to the same exact remote ASN. This has showed up, as I said again, it's called metric in many cases, we call it metric. And this is really the key to the metric system. We're using the metric value, the metric attribute as a way to break ties between routes heard from diverse ASNs. So here's the example of historical med use I was saying. AS1, AS2 are speaking, they have 2 physical links between them. And AS2 wants to tell AS1, hey, I prefer that you send me traffic on this link. So AS2 is going to set a med of 10 when he announces to AS1 on this link. He can set a med of 1 when he announces on this link. And AS1, if he's doing what he's supposed to be doing, is going to always select this link as long as it's up. In the metric system, here's how we utilize med. What we do is on our side, within our network, when we learn routes, we set different metric values. So a very simple example, traffic to 10.0.6.0. Normally we have 3 equal cost paths. Link AS1 will be 146, 2 will be 246, and 3 will be 356, 3 AS hop counts. By setting a metric, when I learn this route from AS1, I'm going to set a metric to 100. When I learn routes from AS2, I'm going to set it to 200. And when I learn from AS3, I'm going to set it to 300. Well, as my router is comparing metrics, lowest cost wins, I'm effectively going to send all that traffic out AS1. And this is really the master magic slide. And if you understand this much, you can go off to another talk, because this is really all I had to talk about. But if you want to see a little more in depth, please stick around. I'll show you some more. I want to talk about the origin code just for a moment here. So origin code was initially intended as a hint to tell how a route entered into the BGP table. Again, there are 3 values for the origin code: internal, external, or simply unknown. Internal may be coming from another IGP, external may be redistributed, and unknown is just a wild card. I told you it's not really used consistently on the internet. I went ahead and I took a look at 3 full tables from 3 from 3 major US carriers, just as a sample set. One major US carrier had 0 routes that were external unknown. 100% of these routes, 275,000 routes approximately, were showing up as internal. Well, another one of the carriers had 0.5% of the routes, 1,367 of them, showing as external, and 22,000 showing as unknown. Another one had 4,000 as external, and another 22,000 as unknown. Really inconsistent. They're not actually all carrying this widely over the public internet, and many times they may be modifying themselves. So my take is, since it's arbitrary anyway, it's not used consistently, I feel safe throwing it away. Why do we need to fix the origin code? Well, the origin code sits right here between our AS path length. Oh, look at that, my battery's dying. It sits right down there between our AS path length and our med. Because it's inspected before the metric, it can actually interfere with what we're doing. Let me show you an example. So in this case, we have a route to 10.0.6.0. And as I told you, this is taken from the previous slide where we set the metric to 100 from AS1, 200 from AS2, and 300 from AS3. Well, we would expect with a metric of 100 that AS1 would be selected. Oh no. AS1 is telling us that route was known with origin EXT. And AS2 was telling us, and AS3 were telling us origin INT. Well, it turns out that INT, internal, is preferred over external, which is preferred over unknown. Because origin is compared first, it actually interfered with our ability to route based on the metric value. And in fact, the AS2 path is selected even though its metric is 200. So let me introduce the metric system in depth here. The goals of the metric system are to save costs, of course, by ensuring commits are met, and also by ensuring that your overage, once you've met your ISP commitments, you're sending your overage to your less expensive ISP. You're going to improve performance because typically a path with a shorter AS hop will mean a better network path. You'll get consistent, predictable results. By setting metric, your routers will always make the same decision regardless of how old the route is. ISP flaps, when he comes back in, the metric is set, the decision is retained. It's deterministic, as I said, so it's not subjected to shifts based on a route being withdrawn 2 hops away or an ISP flapping. I found it's pretty easy to administer once you have it set up and running properly. And you're able to minimize your manual adjustments. And therefore, you're going to minimize the amount of time that an engineer needs to spend manually manipulating your BGP table. You're going to get the most bang for your buck by setting a few catch-all rules. And it does have very good multi-vendor support, whereas some attributes are proprietary to a specific vendor using a weight or preference. MED is properly carried across all vendor options. So you're convinced, you're sold. So what's next? So there are some preparation steps to convert your network over to the metric system. There are some base configurations you need to apply. Then one of the most important steps is selecting your tiebreakers. And then there's some optional tweaks that you may or may not need to apply. So here are your preparations. Your prerequisites, of course, your routers have to have enough RAM to hold multiple field BGP tables with soft reconfiguration. In some cases, your routes may be slightly abbreviated. There are some platforms which max out at 224,000 or 206,000 routes. There are some workarounds for that, and if you're interested, look 2 nanogs ago at a lightning talk that I gave. The cost or capacity of your WAN links, your actual transport links, are not considered. So your WAN backhaul isn't really desired. We're going to try to stay within a metro region where you may have a flat rate metro giggy or 10 giggy or dark fiber. This is going to work best, as I said, work best in networks that can be divided into small regional islands. And your network staff that are responsible for maintaining your BGP, they really want to stay involved in communities such as NANOG, ARIN, some of the European Asia-Pac communities, because you want to know what's going on. There are some major changes that sometimes occur within ISPs, acquisitions, AS number changes. So you're going to want to stay on top of that. So let's get you prepared. So if you're not already receiving the full routing table from your ISP, you're going to want to head and open a ticket, call them up, and have them send you that full table. You're going to want to make sure they also send you communities. We're going to talk about communities a little later. And some of the tweaks you're going to have to make are based on route communities that are getting tagged with a prefix that's being sent to you. So make sure you get communities from your upstream ISPs. More importantly, make sure you get community definitions from your ISPs. And this can sometimes be a challenge. Some ISPs, the first line support, you ask them for community definitions, and they'll come back and say, ooh, that's proprietary and secret, and I can't give you that. So you might need to work a little hard to get that. In some cases, you can get it very easily. You're going to want to configure, excuse me, you're going to want to enable what's metric comparison across diverse next hop ASNs. As I said, by default, MED comparison is only performed when the next hop upstream ASN is the same. You're going to want to configure you're going to want to enable soft reconfiguration inbound if your platform requires it, depending on your router hardware. You're going to want to identify some good times to make changes, and you might have to schedule some change windows in order to get approval to make these adjustments. And you're going to want to clean up and unify your existing routing policy. So if you have a stale policy that was written by one guy 3 years ago, and another gal 2 years ago came in, and then you just came in a year ago, and you got weird, crazy stuff going all over the place, you're going to want to go ahead. This is the time to clean it up. Let's talk about communities a little more. So community tags are additional attributes that can be sent with a route when your ISP gives you a route. And they can carry additional information in addition to AS hop, prefix length. They might tell you about the type of route, if it's a peer or a customer or a transit route. They might tell you location of the route. Did I hear this in Los Angeles? Did I hear it in Amsterdam? They may give you a region, North America, South America. Pretty much all ISPs, all reputable ISPs, are using community tags internally for their own purposes. It's a survival technique. You got to have it. Most major ISPs actually don't share them with you, though, when you're taking a full BGP table. That's not their default configuration. But they will do it on request. I so far haven't come across a single ISP, reputable ISP, that will refuse to send you communities if you ask for it. One problem with communities is there's no standard format. What's a peer? What's North America? What's Amsterdam? So having communities get sent to you are pretty useless without actual community definitions from that ISP. Let me show you an example of how diverse community definitions can be. Using a couple great ISPs in the example here, NLayer and Level 3, I happen to be fans of both of them. In order to designate a route as being learned from a customer in Los Angeles, an ISP like NLayer will send a single community, 4436, which is their ASN, and then 41718, which is it's called a stacked number that where each digit or pair of digits may have some significance. An ISP on level 3 will send you 4 separate communities. One will tell you he's a customer. One will tell you he's in Los Angeles. One will tell you he's in North America, and one will tell you, I forgot what the last one is. Doesn't matter. You get to look it up. By the same token, a private pair in Amsterdam, NLayer will send a different stacked value, 32220, and level 3 will send 4 different attributes. And the first one being that it's a peer, the second one being it's in Amsterdam, and the third one being a region, etc. You may have to refer to these communities later for fine-tuning, so it's best to have them ready, available in your arsenal from the get-go. Where can you find definitions for the communities? Well, of course, lots of ISPs will publish them on their own website. I gave as an example here NLayer, who publishes a very concise and easy-to-follow single sheet. Some of them will publish them in a routing registry. So level 3, for example, you just run that whois command, and you'll get screenfuls of community definitions. In some cases, they don't publish them publicly. You're going to want to ask your ISP directly. And as I said, this sometimes can be a challenge. You might have to go to your sales engineer or your account rep or get escalated through the support chain until you finally get it. And our good friends over at OneStep, Charles Gucker and Company, they have an unofficial collection there. There's a URL over there, onestep.net communities. And they have an unofficial collection that people have been contributing to, which can be quite helpful in a pitch. So let's talk about getting prepared. Your base configuration. For Cisco, of course, you're going to enter BGP configuration mode, router BGP or AS number. You're going to enable the metric comparison for routes heard from diverse ASNs. It's very simple, BGP always compare med. You're going to want to configure the safety net against missing metrics. As I said, some routes will be sent to you without any metrics. Or you may have a typo in your policies where you forget to set a metric. So we're going to turn on BGP best path, med missing is worst, meaning if there's no med, set it all the way up to the maximum value, which is 4.2 billion, because of 32-bit integer, excuse me. And that route will actually not be selected unless there's no other available route. Go ahead and enable receive route storage. This is called in the Cisco world soft reconfiguration inbound. And you're going to want this because later on, as you're doing tuning and tweaking, you're going to have to reread these routes and reapply different metrics. And also go ahead on Cisco, you need to enable the ASN:ID format. Like I showed you here, 3356:123. Well, by default, still today in the year 2009, Cisco doesn't show you communities that way. They use the older long string format. Go ahead and just type IPBGP community new format, so you can read communities in a human-friendly format. On a Foundry, very simple, very similar. You're going to enable BGP, router BGP. You're going to turn on the always compare med, almost the same exact command from Cisco. Med missing is worse, again very similar to Cisco. And soft reconfiguration inbound, again a very similar command. On a Force 10, BGP mode, BGP always compare med, soft reconfiguration inbound, and med missing is worse is actually on by default. So hey, there's one less step for you for your Force 10 fans. In the Juniper world, go ahead, enter protocol BGP mode, turn on the always compare med path selection option. Soft reconfiguration is enabled by default, in fact. And med missing is worse. I don't remember why I didn't put it on this slide. Google it. Sorry, Bing it. Next step in getting prepared is identify times you want to make changes. So if you're doing traffic balancing, you can really only know the effectiveness of your changes if you're making the change during your peak traffic periods. Go ahead, pull your graphs, daily, weekly, monthly, historical graphs, find those peak periods of time, because that's where you're getting billed in your 90th percentile, and that's where you have your most risk of congestion, obviously. You may have to prepare your management and your operations staff. They might not want you to make changes during peak periods. So it may take some finesse. It may take a few meetings. It may take a few more than a few meetings. But if you're not making your changes during peak periods, you're not going to know until maybe 12 to 24 hours later how effective your changes were, and you might find yourself making emergency back-off changes. You're going to have to make you may have to make some practice runs during off-peak hours. You may have to demonstrate to your management, your operations staff, that you can actually make these changes soft without causing any outages. BGP is a wonderful protocol, a wonderful make-before-break style protocol with software you can config in. If you're doing it right, you can typically do this at any time of day without causing any outages, as long as you don't do something silly like congest a link. So you're all ready. You've got to clean up. You've got to scrub in for surgery. You've got to clean out all of those policies. And you want to start with a base, nice, clean catch-all policy that does, very simply, accept all your BGP routes, reset your origin to type internal, reset your metric to 0. There's your starting step. Once it's done, see what you got. Let's proceed with configuring your metric system. So for the remaining examples, I'm just going to show you Cisco IOS and Junos. Foundries and Force 10s are very similar, not identical. So if you're a Foundry or Force 10 or other vendor, please check your documentation. Don't just copy these configs right out. Also with the routing policies, there are so many ways to write a routing policy. And there's so many different styles. So you're going to want to look at your own network. You might have your own precedents. You're going to want to go ahead and adapt that if at all possible, so that you minimize the engineer confusion. If you have absolutely nothing going on, you can take some of this as an example. You can drop me an email, send me a call, give me some more assistance. So base policy for iOS, as I said, we're going to write a route map. Going to catch all routes, so there is no match clause, because by default he'll match anything. Going to reset the metric to 0, reset the origin code to IGP. Go apply it to a neighbor by simply entering BGP configuration mode, and neighbor, pure IP of that neighbor, there's your route map for all inbound learn routes. In Junos, you're going to write a policy. Excuse me. Write a policy. Within that policy, you're going to have a route origin policy, which simply sets origin to IGP. You're going to have a import from ISP, which, again, there's no from statement, so it's going to catch all routes. Going to reset the metric to 0 and accept all routes. Apply it to the neighbor. In this case, we're applying these two policies in sequence to the neighbor. One just resets the origin and goes on the next policy, and the next one, of course, does our catch-all statements. Let's talk about some more detailed configurations. So once you've set your base configs, you've gotten your maintenance windows, you've scrubbed in, everything's clean, you get to start really hitting into getting deep in the metric system. So there are 4 stages here. Typically, you might only hit the second stage. First stage, we're going to fix the route origin attribute, as we discussed. We're going to go ahead and we may have to add some prepends. I'll talk about that in a moment. The second stage, we're going to set some broad strokes. We're going to set some tiebreakers for AS hop ties. Like I showed you before, you may have 3 possible routes and 3 AS hops to that destination prefix. We're going to have to set who wins that tie. There may be some general selection based on some ISP information. So using some communities, you may want to say, I prefer sending these peer routes to this ISP, these customer routes to that ISP. The third stage of metric system is, if you still need additional balancing, you may have to set some specific targets based on the destination network, 2-3 hops away. You're going to have to understand those target networks. This is where really flow-based statistics becomes valuable. If you're already at this stage, you're probably going to want some net flow collection and analysis based on ASN prefix. And in this case, I prefer to make my third stage changes based on ASN rather than specific prefixes, because prefixes can and do change over time. ASN changes a lot less frequently. In the final stage, there's some additional fine-tuning. I find that I rarely enter this stage, but I'll tell you a little bit about that. So let's go in depth here. So the first stage, I said we fixed the route origin attribute. We may have to set some AS prepends. Route origin, we already did during the cleanup stage, but go ahead and double check. Do a show IP BGP, neighbor routes, do a show route receive protocol BGP, neighbor IP. Go ahead and make sure all those attributes are set to internal. And as far as AS hop goes, equalizing the playing field, check, do any of your ISPs insert an extra local ASN before you get to the backbone ASN? This is pretty, there are a few large ISPs that will do this, where they may have a backbone ASN and every region has its own local ASN. You're peering with the regional ASN and you have to go through the backbone ASN before you hear any additional routes. This, unfortunately, will artificially pad your AS path to that ISP. It adds one extra AS hop, which is really of not much value, not much consequence, but it will affect your routing decisions. So if so, equalize the playing field by adding one hop to everybody else. And once you've done that, you take your baseline measurements, your traffic levels, your performance, make sure your customers are happy, you're not congesting your links, and decide where to go from there. Go in depth here about that extra ASN. So for example here, your ISP AS1, you happen to be connecting them in the region of what they call AS7. So every route heard through AS1 has this extra AS7 in a path. And the effect, for example, going to 10.0.10/24, 10.0.10 is very obviously connected off AS1. You should be preferring your link via AS1, well, AS7 to AS1, because it really is the shortest hop. But what ends up happening is it appears because of that extra hop that your path through AS2 and AS7 are both 2 hops away. And you have another equal cost. How do we fix it? What we're going to do is when we learn the route, we're going to actually prepend AS2's AS. So now our routing table looks like this. We see that, again, to 10.0.10. Through AS7, it's 2 hops, 7 to 1. Through AS2 now, it's 2 to 1. We actually are allowed to add the ISP's AS, believe it or not. And this makes it and then again to AS3, we added 3 as well, just to equalize the playing field. So everybody who doesn't have that extra regional ASN, they get their own ASN heard an extra time. So 221, 33, 541. Oh, laser's back. There we go. Once we've completed our first stage, we have our second stage. These are some broad strokes. This is where we actually start doing some of the initial tuning. We're going to set those tiebreakers, and we'll do some additional general selection. So what the tiebreaker is that we're going to set a different metric value for each ISP on that catch-all policy that we initially wrote that set a metric of 0. Well, now we're going to change it to a different value. And you're going to have to experiment with different sequence of tiebreaker metrics and take measurements along the way. And this is the kind of thing you want to do during peak periods. You set them one way, you wait 30 seconds to a minute, check out utilization, set them another way, check utilization, until you have something that you like. Once you're done, you decide on your final tiebreaker that most closely meet your goals. And if the tiebreakers aren't enough, then we're going to go ahead and do some community-based decisions. And you may even be done after this step. Go to Starbucks and come back and configure Rancid or something else that's sitting on your project list forever. So in the AS path tile, like we said before, 10.0.6.0. Well, there are 3 paths, 3 AS hops each path. By default, remember we set our catch-all to 0. So which route gets selected here? Well, how are we going to decide which route gets selected? So first of all, we need to understand the definition of when I say the word ISP tier. The ISP tier is unfortunately a contentious term. It used to have technical relevance, and now it's been exploited by marketing. Oh, I'm a tier 1, I'm a tier 2. There's even a guy out there called tier 0. So really think in terms of next hop AS reachability. How many ASs can you get with just 1 extra hop versus going 2 extra hops, 3 extra hops? You want to observe the AS path differences to some of the larger eyeball ISPs. Remember, I'm coming from a content world here. Poke around your BGP table. Look at your 5 largest target networks, if known, and check your path out. And go ahead and compare some traffic performance measurements at each step. And don't forget to give yourself some time. Maybe give yourself 5 minutes, 10 minutes, 15 minutes to see what the result of your changes are before you make any additional changes. And if the first tie-breaking scheme doesn't work, it's not a big deal. Just shuffle those values around. Try again, see what happens. So show you an example here. So we went ahead and we decided that AS1 is going to win all the ties. And we decided that by setting a metric of 100 on AS1, a metric of 200 on AS2, and a metric of 300 on AS3. So going back to 10.0, excuse me, just a moment. So we're showing you here is just all the best paths using that scheme. Going back to our bottom 10.160, the path through AS1 is selected because he only has a metric value of 100. That's the best path. And metrics of 200 and 300 aren't being installed in the forwarding table because they are inferior. Well, let's say that didn't actually work for us. So we're going to go ahead and shift it around. So where initially we said AS1 was 100, then 200, and 300, we're going to shift around, and now AS1 is going to be 200, and AS2 is going to get the 100. Well, again, looking down, just scrolling to the bottom here, the 10.1.6, of course, now we're selecting by AS2. And you can see, go back and forth, just looking at color comparison here. how some of the route decisions may have changed, some of the further ASNs. Let's say that didn't work out for us. So we went ahead and we shuffled them around. So now AS1 was getting 200, but AS2 got 300, and AS3 got 100. Well, now take a look at 10.1.6. Well, now we selected via AS3, of course. But you've got to watch out. What just happened to 10.1.4? What did happen to 10.1.4? Well, 10.1.4 is actually now going via AS1. So by swapping AS2 and 3 around, so previously AS2 was 10.1.4. Now just by swapping 2 and 3 around, now AS1 wins 10.1.4. So just make sure that's what you wanted to do. Here's how you configure the tiebreakers. In the Cisco world, in iOS, you'll have one policy, one inbound policy per ISP. And in this case, ISP1 will get a metric of 100, ISP2 metric of 200, ISP3 metric of 300. Very simple. In Junos, just as easy to do, your catch-all term, metric 100, 200, 300. I'm going to here's some actual numbers. So we had a network that was doing approximately 10 gigabit per second of traffic, and he had 3 ISPs, and all we did was set the catch-all metric. And this is how the traffic shifted around. So by setting AS1 to the tiebreaker, AS2 to secondary, AS3 to tertiary, we were sending 8.5 gigs on one link, 1.5 gigs on another link, and immediately 0.2 gig, 200 megabit per second on the third link. Well, anybody can look back and say, well, that's a really poor balance. 8.5 gigs, in fact, at peak period, at 5-minute averages, you actually run the risk of congesting link, of course, and we don't want to run that hot. So we want a little bit better balance. So we went ahead and we shifted AS2 to be the tiebreaker, AS1 secondary, AS3 tertiary, and we got a slightly better balance between AS1 and 2. We now shifted 4 gigabit per second from AS1 to 2. We're getting 4.5, 5.5, but AS3 is still only getting 200 megabit per second. Well, that's not very good utilization on my 10 gig link that I have to them, is it? Especially, I think in this case, I think we're paying a port fee to these guys, so that's really bad. So, okay, we shifted it one more time. Now, AS3 is the primary tiebreaker, AS2 secondary, AS1 is tertiary, and now we got a much better spread, 3.5, 4.0, and 2.7. We're using all links pretty effectively, where we've minimized our chance of any single link congested. Well, it turns out, we got a fairly acceptable balance by tiebreakers. I'm going to show you some more detail on this. Well, I'm going to talk to you about how we actually managed to successfully balance based on commits. But this is just trying to get some kind of even traffic spread with minimal configuration. Again, one thing I configured per ISP, the catch-all metric, and I managed to spread traffic across the links in a fairly effective fashion. Then afterwards, you got your great balance, and you got your 3 links up. That's wonderful. But now you have to think failure scenario. So pay attention to the balance, who's secondary, who's tertiary especially. Because what happens if the lowest cost breaker goes away? If that AS3 were to go away, would the resulting balance be satisfactory? Maybe your secondary, tertiary, maybe need to flip them around. You're going to want, of course, schedule a test to confirm this. Don't just guess it. Take that link down in a maintenance window. See what happens. And, of course, adjust the secondary, tertiary sequence accordingly. The next thing we're going to do is, I showed you some broad strokes where we set metrics, and we got a fairly good balance. But it turns out that that didn't meet our requirements for cost. So what was the next step? Well, we said, I can balance based on destination AS or a prefix, but I'm going to try something different. I'm going to go based on communities. So if you have 2 similar upstream ISPs, in that case AS2 and AS1 were very similar Tier 1 ISPs, too many of the AS hop counts were equal. It was 2 hops to get to so many of our destination networks. So too much traffic went, let me go back and show you here. So too much traffic, too much traffic went to AS2. We're trying to get it a little bit closer between AS1 and AS2 because too many destination networks were only 2 hops away. So that's the wrong button. Yep. So what we decided instead was we're going to go ahead and take that extra information the ISP is giving us in the way of communities, and we're going to select some extra criteria, and then we're going to sway some traffic based on that criteria. Either peers versus customer, country, continent, region. Maybe you know one of your ISPs has much better access in Europe and much worse in Asia-Pac, and your other ISP has much better in Asia-Pac and Europe. So you're going to say, okay, I'm going to pref this provider's Asia-Pac over the other provider's Asia-Pacs. So the example here is to AS4 specifically. We're able to learn via community strings how that the AS4 to AS1 relationship is a customer, where AS4 is buying from AS1. The AS4 to AS2 relationship is a peering relationship, so AS4 and AS2 are peering with each other. And AS3 to AS5, AS3 is actually buying transit from AS5. And again, the reason you may pay attention to this is peering links and customer links and transit links have different dynamics as to how the likelihood of them getting congested, and if they are congested, the timeline with which they'll be corrected. So in this case, AS1 for a customer, they tag routes with 100, and a peer they tag routes with 200. AS2, they have a different scheme, just demonstrating different schemes here. They maybe use 555 and 666, and AS3 maybe uses 4000 to tag a transit route. To go ahead and configure in Cisco IOS communities, it's nice to define the community list up on top, so you can then refer to them by a human readable name. So AS1 customers, just go ahead and give it 1:100. AS3 transit, 3:4000. And then when you want to reference them, you simply will have in your policy another stanza 20. You put a little description there to make it easier for the next person after you to figure out what you're doing. I want to prefer these customers. So I'm going to match a community. It's called AS1 customer. And I'm going to go ahead, I'm going to set that metric. Remember our best tiebreaker was 100? Well, I'm going to beat the best tiebreaker, so I'm going to set this metric of 50. So it has to be better than the lowest tiebreaker. And let's say on ISP3, I want to depref their transit. I don't want to send them transit-based traffic if I have it better route one of my other ISPs. So I'm going to say, okay, match a community transit, and go ahead and set that metric to 400, so worse than the worst tiebreaker. In Junos, very similar. You define a named community, and you reference it in your policy from community metric, from community metric. So here's what it looks like. So let's say we just started with the metric system. And we have these two routes here. You know, I don't like this route for 10.1.4 because I set AS2 is winning over AS3, even though it's equal AS hops. AS2 is winning to AS4. I don't like that route. And now also AS3 is winning to get to 10.1.6 because it's only 1, 2, 3 hops away, and I set him to 100. I don't like that route either. So I want to make some changes. Well, how do I make changes? I'm going to make it based on community because I happen to know that this is a peering link and that's a transit link. And those are two things that, for whatever reason, I happen to not like. So what I'm going to do is I'm going to set, for AS1, he had the worst metric of 300, but I'm going to add the policy saying prefer customers. And for AS3, I'm going to add another policy saying depref transit routes. And the result is I just shifted 10.1.4, where previously 10.1.4 was going to AS2 via metric. Well, now it's going to AS1 with a metric of 50. And the same thing for AS6, where previously it was going out AS3 with a metric of 100. Well, now it's going out AS2 with a metric of 200. Because remember, we increased it to 400. So now we're selecting 200, which is a lower value. Here's some actual numbers. So going back to our previous example where I was showing you how we actually got a really good balance using simple metrics, well, we actually had 10 gig links to 3 ISPs. We had a commit of 4 gig to AS1, 4 gig to AS2, and 1 gig to AS3. Those were our commit levels. So obviously in the previous example where we're doing, in the previous examples we're doing 5.5, 3.5, and 2.7, what ended up happening, we were under commit on one of the ISPs because we had a 4 gig commit, we're only sitting 3.5. And then we're over commit on another ISP, we had 1 gig, and we're sitting 2.7. Well, that means we're essentially burning 500 megabit per second worth of traffic that we're paying for and not utilizing. So by taking our base metric system and simply applying pref customer and depref transit, we're able to get to 4.5, 4.0, 1.2. Great traffic balance. I met my commits of 4, 4, and 1. I applied 2 tweaks, and I can go on with my day and configure Rancid. If that's not enough for you, a second stage is enough for you. You're going to have to go into a third stage. You're going to have to make some decisions based on specific destination networks. So most networks don't have to go into this level of detail. Like I showed you an example of a 10 gig network. We didn't actually have to go this far. But, which is good, because this work is a little bit more demanding. So you really have to know your largest destination networks. Maybe, usually you need only the top 5, top 10. Anything beyond there, there isn't that much impact. Actually, I put top 20 in this slide. I should read my own slide before I talk about myself. Sure, get your top 20. You're going to find you're only going to really have to manipulate the top 5, maximum the top 10. It's better to make changes if you're going to do this based on ASN versus prefixes. At any point in time, an ISP can grow and give back a /17, pick up a /15, renumber, and they don't have the courtesy of telling you, of course, when they choose to renumber. So more likely, ASNs will stay static and stable than IP blocks. So an example here of making a decision based on a destination network. So this was our baseline. So we set our deep-pref transit. We set our tiebreakers 300, 200, 100. We have this route here to 10.16. So 10.16 is now going out AS2. Well, we want to use AS1 to go to AS6, to get to AS6. We can't just change the catch-all metric because that'll change too much. But we know specifically we're trying to get to AS6. So what are we going to do? Going to go ahead and in Cisco make an AS access list with a single ASN, AS6, and we're going to go ahead and say, okay, any routes coming from AS6, go ahead and give it a metric of 50, which is better than the best tiebreaker. Junos, very similar. Make a named AS path, and put in your policy any routes heard from that AS, set metric 50. And of course, the result is now AS6, or sorry, 10.160 has now moved to AS1 with a metric of 50, where previously he was AS2 with a metric of 200. Some gotchas on destination networks. So overall, you want to try and minimize this step. You want to focus on those broad strokes. Yes?
I'm only dealing with Juniper here, so I don't know exactly how those regular expressions work. Say dot star, dot star.
Yeah, the...
Is that going to include networks that have a 6 anywhere?
No, good question. So the question is, does dot star 6 dot star, will that include an AS such as 161? Very good question. So when you're doing AS paths in Juniper, they have what they call an AS path regex. It's not a straight string-based regex. When you're in AS path world, dot star means any AS path, so it has built-in space padding in there. So yeah, it doesn't. It's not any numerical value that has 6 somewhere in between. But it's a good question. It's a kooky Juniper AS path regex thing, right? No? Is it standard regex? Yeah. Okay. So it's true. iOS has the crazy underscore stuff, right? But Juno-S, the dot star is pretty much equivalent to the Cisco underscore. So it means any number of spaces and ASs between, and any number of spaces ASs. But it's safe to do. Okay. So gotchas about this, about starting to dive into destination networks. So I told you it's definitely more work. The network engineers that are doing this work, they really need to stay up to date. Internet is fluid. It does change. You can't just rest on your laurels, say, hey, I got it, and I'm making some destination ASs. You got to keep your eyes open. You got to keep your ears open. Large eyeball backbones might sometimes shift. They might bring up a regional ASN, may take down a regional ASN. You're going to want to make sure you're going to shift only one destination network at a time. Give yourself time to observe the results. If you're not happy, undo your changes before you do the next change. So I've been in networks where I found they've shifted 25 destination ASNs because they added one, it wasn't enough. They added another one, it wasn't enough. They added another one, it wasn't enough. And they had all these 25 this way and 17 this way. It was ridiculous. We rip them all out. We do 3 that way, 2 that way. We're done. So go ahead and roll back your change if it's not sufficient, not satisfactory. Move to the next one. If you don't have useful flow data, this really is better with flow data. But if you don't have flow data, go ahead and try using a backup link. So if you have backup links to your ISP that normally don't take any traffic, just shift one ASN at a time to that backup link and see how much traffic it's using. Doing it for 15 minutes, not going to cost you anything, not going to cause a performance problem, or shouldn't if your ISP knows what they're doing. If you don't have a backup link that's normally idle, but you do have sufficient capacity on other links, go ahead and move all your traffic off a specific link for a brief period of time, shift that traffic over, take measurements. Again, this is poor man's flow data, right? Flowless flow data. The final sequence here is some fine-tuning. You rarely need to do additional fine-tuning. I've never had to do additional fine-tuning, and I've done this at over 10 networks. Usually the first 3 stages are all you need. But if it's not sufficient, you may need some additional tweaks. Maybe the tiebreakers aren't doing it for you. So you're going to want to identify other paths. And once you do, you want to look at a couple of attributes. So you may have to insert an ISP's AS to shift traffic away from that ISP. And when all else fails with a softer metric system, you're going to have to go ahead and have to use local pref. You're going to have to increase the value of your local pref. And sometimes you're going to have to do this to work around your cost savings as well. You may have $10 meg here and $15 meg there, and you really don't want to use that $15 meg for overages. So example of setting local pref. So in our case here, traffic to 10.1.4. Well, 10.04. Wow, I had a typo on the previous slide. So going to 10.04, let's say you want to send 10.04 by AS3. There's nothing you can do with metrics that will cause AS4 traffic to traverse AS3, because it's always going to be one longer AS hop away. But if you know for certain, for whatever reason, you've got to send that by AS3, your best bet is simply set a higher local pref. In this case, I set local pref 200. It's hard to read because it's yellow, sorry. Local pref 200, go ahead and force that traffic out AS3. Similar with traffic going to AS3. Let's say for some reason, this is where the cost trickery comes in. You actually don't want to send that traffic directly to AS3. You want to send it around the long way through AS1. Using the metric system, no matter how hard you try, you will never get it to go out AS1 because it's a much shorter path to AS3. Go ahead and increase that local pref to 200 when you hear the route from AS1. Just send traffic all the way around. By this time, you should be successful. Your metric system's working, you're having a great day, you went out to Starbucks, you came back and you played some WoW. Once you've got it pretty stable, your future tweaking should be pretty simple, pretty minimal. Go ahead and get your monitoring system going. Get your bandwidth going. Get your bandwidth counts. Get some alarms when running over so you're not called in by your boss saying, I thought you had this down pat. Donnie helped you out and now we're overcommit on one link or we're over congesting another link. So make sure you're alarming on bandwidth thresholds. A couple alternate ideas here. I'm talking fast. Let me talk about some alternate multipath strategies. So a lot of the modern hardware allows for automatic multipath if you're connecting to the same ISP over multiple links on the same router. Some products even support what can be called multipath multi-AS, which means you have a link to AS1, AS2, and you just want to automatically send roughly 50% of your traffic out both links. Go ahead and check your documentation to see if it's supported. Go ahead and test in a safe environment, because you might be surprised with the results. I'm not going to cover in detail the multipath, because different hardware platforms either work or don't work. Some of them will actually flap your sessions when you make the change. And most of the time, you're not just looking for a 50-50 split of traffic. Multipath also is dependent. Success is based on hash algorithms. I found that it's not. I might use it where I might use it in one limited case where I have multiple links to the same exact ISP. So let's say at AS1, maybe they're not ready for 10 gigi ports in your city. So they give you two 1 gigi ports. In your other ISPs, you have 10 gigi ports. So you want to just want to balance. You know that you want to send 1.2 giga traffic to AS1. You have these two 1 gig links. Well, the easiest way is just turning on multipath for that single ASN, and your router will usually hash pretty evenly across both links to AS1. And then the example here on the routing table is that traffic going to AS1, there will be two available paths, and then your ECMP logic and your ASIC will take care of balancing on the links. Some common errors when configuring the system, when using the system. So these are some errors that are going to result in unacceptable balance or non-deterministic results, and they're going to lead to an inconsistent traffic balancing scheme. If you're not setting metrics for all your routes from the start and you're relying upon those built-in tiebreakers at the very end, oldest route, lowest IP, highest IP, phase of the moon. Other problems are if you're not setting unique values, incrementing values, meaning you're not going to set a metric of 100 over here and a metric of 100 over there. You're going to want to make sure one is a 100 or a 200 or 300, 1,000, 2,000, 3,000, whatnot. You want incrementing values. You don't want to set the same value on multiple ISPs. Other problem you run into is if you have inconsistent metrics that may result in different selection based on different routers. Let me show you what that looks like. This is a case of non-deterministic. So in this case, you set the metric to something other than 0, but you set the metric to 50 on both cases. So looking at the route to AS6, well, great. Well, now instead of being equal at 0, now they're equal at 50. Which route's going to be heard? Again, in this case, it'll usually be oldest route depending on platform, and it can even change if a route session flaps because net no longer becomes the oldest route. Deterministic. So what does deterministic mean when I'm using it here? So deterministic means having an outcome that can be predicted because all of its causes are known or the same as a previous event. I don't know why I threw that in there. Okay, common errors too. This is where we have what I said, different opinions. So you don't have a consistent policy across all of your border routers or edge routers. And in this case, if traffic got sent to border 1 from inside your network, border 1 going to AS4 over here, border 1 actually will choose to take AS1 to AS4 because that's his eBGP hop. And border 2 will actually prefer AS2 to AS4. I don't like this system. Some people end up using this to get load balancing, and they might have half of their servers send traffic this direction and half that direction. I don't like it. I like being a little more deterministic. I like all of my borders to decide on the same exact exit out of my network, out of a specific region of my networks. So the problem with having different opinions, like I was saying, it may be intentional. I found this confusing. It's inconsistent. It usually means you're applying upon equal cost multipath somewhere downstream, maybe in your distribution or your core level layer down from your servers. And if one router goes away, what you're going to find is your traffic balance may shift in a way that you didn't expect, and a way that you actually don't desire. And it makes your life hard during maintenance windows or outage periods. So, in summary, in the metric system, the primary decision attribute is the AS length, or hop count. That allows us to take advantage of the limited performance information that we can get in BGP, which is how many networks away is this prefix. You're going to get your basic balance through your tiebreakers, your catch-alls. Secondarily, if you need to do a little more tuning, go ahead and do some broad strokes, maybe based on community, destination, ASN. Maybe you use fine-tuning if necessary for stuff that can't get done with communities and metrics. And try to minimize those fine-tuning steps, because the longer your policy is, the more complicated it is, the more difficult it is for you to troubleshoot, the next person to troubleshoot, the more chances that you as the author might get woken up even though you're not on shift at 2 a.m. that morning. And now I'm open for questions. Go ahead. There's a mic right behind you, because I think they're recording it, so it's best if you're on mic.
Can I ask why you, when you were doing AS path prepends, why did you prepend the other AS's number? First of all, I wasn't aware that you could actually prepend anyone's number except yourself, your own.
Yep.
But I understand when I'm advertising a route out to someone else for inbound traffic, I should probably only say that I appeared more than once. You know, I'm making myself more expensive. But when you're altering the inbound routes, why were you saying that he was making himself more expensive? Why wouldn't you just prepend your own AS number all the time?
Well, so first of all, you're correct. When you're doing outbound advertisement, you're really only supposed to be prepending your own. It's the right thing to do, and it's the only way to guarantee that will actually get heard. For inbound routes, if I prepend, so imagine you're AS2 and I am AS100. I hear a route from you, the path is AS2. If I go ahead and add my own route, I had the answer and it had to do with looping ASNs. So what'll end up happening is my ASN, and I think it's platform dependent. My ASN actually might appear at the very end of the path. So it actually, right? Am I right on this?
Yeah, basically, if you prepend someone else's ASN, when they hear that path, they're going to drop it because it's an AS path loop.
Yeah.
So what you're doing on inbound is you're prepending their ASN rather than yours. It's just better that way.
Yeah. In some cases, it could be seen as a loop, but also in the other cases, I don't necessarily want to lose that information. So here's what happens: if I prepend my ASN and it actually really becomes the beginning of the path, then I lose that next hop AS information. AS2 is no longer the next hop AS. AS100 becomes magically the next hop AS, right? So I want to keep I don't want to change next hop AS. I just want to make it look like there are more hops. Yeah. But it's a good question, and it's one I haven't thought about for a long, long time. You know, you've been doing something for so long, you already decided why it was good, and then years later you don't always remember why you made that decision, but you know it's right. So, but thank you.
So I had 2 comments. When you noticed that there were some ISPs that were seeing all origin of IGP and some that had a mix, there was a reason for that. There was actually an ISP out there who was intentionally resetting their origin codes to kind of create cold potato routing in cases where they weren't supposed to.
Yep.
And a bunch of people ended up degearing them over that, and a bunch of other people implemented a reset to IGP. So that's why you're seeing that inconsistency. Right.
So it's exactly right. So because you can influence somebody's decision, if you're an unscrupulous ISP, you can go ahead and depref some traffic by resetting origin to unknown or to external. if you don't want to go ahead and accept that traffic. So there are tricks that ISPs can play. I just say, you know what, to hell with you all. I'm going to reset to internal. I'm going to do my own thing. Yeah.
I've never heard the term cold potato routing.
So cold potato routing. So typically routers choose the closest exit from their ASN. So let's say, for example, you have a network that spans between Los Angeles and San Francisco, and you're peering with another network also in Los Angeles, San Francisco. If traffic is coming off your servers in Los Angeles, going to that other network, hot potato means you're going to hand it off as quickly as possible in Los Angeles. Cold potato is where you backhaul on your backbone to San Francisco to hand it off to that other ISP. The reason that you might not want to do cold potato is you're utilizing that long haul capacity on your network that you're paying for. Hot potato actually is kind of the default behavior because eBGP is always preferred over iBGP for loop avoidance. So you're not going to want to send it on your internal network if you actually have an external exit that's closer. And that's what hot potato versus cold potato means. And typically most networks like the hot potato because it's a cost savings to them.
So why would you want to create, why would you want to force yourself to send it to a faraway location and exit it?
So you might have a congested link between you and that other network in Los Angeles, and you know you have capacity in San Francisco. So for performance reasons, you're willing to backhaul it to satisfy your customer base and hand it off to them in another location.
And the other comment that I had was a lot of times when you make these policy changes, it takes a couple minutes for the routers to go through and apply them. Specifically, there's a difference between doing a hard BGP reset where it gets more prioritization that it wants to converge immediately versus a soft clear. So there might be times when you might have to wait 20, 30 minutes for it to fully process after you do a soft clear. And what I've noticed on Cisco and Juniper specifically is that they walk the table in prefix order. So if you want to know when it's done, pick something that's as close to 255 dot whatever as possible and just check that. And when that one's done, then you know the whole table's been completed and then you know what the effect actually is.
Yeah, absolutely. Yeah, thanks. I've never seen it 20 or 30 minutes, but I think that's going to depend on size of your network, how many hops if you're using route reflection, and also the CPU load of your routing devices. In the Juniper world, the trick that I use is show system process summary, and you watch that RPD process, and when the CPU utilization on your RPD process goes down, that usually is an indicator that he's done with his route decisions. Right. Now keep in mind, I'm really working on fairly simple networks here. In the Cisco world, it used to, in that if you read the books and you read the docs, you're supposed to do BGP summary and look for synchronized table versions. But networks are too large nowadays. I don't think I ever catch a synchronized table version nowadays. It's very difficult to catch. You have to have a very, very idle network for that to happen, so it's no longer a good indicator. Hi.
Hi, Chris Woodfield, Internet. Wanted to add a little bit of info to the cold potato routing versus hot potato. I don't know if this happens that much anymore, but I do remember back, when there were a lot of backbones that were heavy net pushers, the above nets and the exoduses that were having trouble getting peering because their in-out traffic ratios were so great. So what I know what I know that some of those pusher or backbones did was said that if you peer with us, we will listen to your meds, and we'll cold potato in exchange for you being willing to peer with us.
Yeah, so in general, cold potato is usually more expensive for the network who's cold potatoing it, and it'll only usually happen for self-fulfilling, self-satisfying reasons.
Yeah.
Absolutely.
Yeah, because other carriers, otherwise wouldn't want to peer with those types of networks just because of the imbalance of the in-out traffic ratios.
Yep, absolutely. So. Exactly right. Exactly right. Any other questions?
Great talk, Danny. Thanks.
Hi. Thank you.
The question I had was for keeping track of what you've done. I know a lot of people who actually do this BGP-TE. They have some peering link that's congested, so they move it to a paid transit, and people forget. You come back 2 weeks later, it's still going, even though you've upgraded your peering link, it's still going there. Have you worked out any system for just keeping track of things? What you've done that's quote-unquote fine-tuning or deviation from policy versus what is your actual policy?
Yep. Yeah, we've done it two different ways. We've had two different requests. One was graphical, one was tabular. So we did it in Visio, which was a topology of the network with a whole bunch of text notes in all the right router locations. And that worked for that. The engineer who asked for that wanted something he could just put up on the wall for his other people and had a place they can quickly look. The other way we did it was we just did it in a simple Excel spreadsheet where we listed, we did a table of the regions, the ISPs, who won the tiebreakers, and then who got the additional tweaks. And then when we added communities, we add them on. So I don't think either of them is perfect. Both of them were satisfactory to the client who paid us for that work, and so we stopped there. But I have not yet found the perfect solution. I really wish I have.
So nothing automatic, nothing that updates, say, these are deviations from policy.
So obviously, it should be trivial to parse your configuration and pull that. The question, though, is so what we actually had to do in the tabular version, we actually every time we made a change, we added it was just Excel, so we added another tab to Excel because they needed history going back. Oh, well, what just changed from here to here? So we had to keep it, and we put the tab on the bottom of the Excel was the actual date. And then the changes, when we made changes, we highlighted those cells in yellow. So when you go from date to date, it's pretty easy to see what the delta was. So if you have a bad shift, you can always roll back. I can see ways you can do that in automated fashion. That makes sense. We haven't spent the time doing it. But representing the information, I still don't have a clear picture. If I had unlimited time and funds to do it, I don't know how I'd represent it properly so that everybody would understand it. It's still a little bit tricky. So you have a finite group of people that are using this information, and hopefully they all know what they're doing, unfortunately. Or if you're Internet, you have a magic piece of software that does it.
Actually, what I was going to mention was the fact that one thing that that we do actually is we don't telnet to routers and configure at the command line.
Yeah.
We do everything in a TFTP file that we then download. And one thing that lets you do is it lets you put comments in the TFTP.
Yep.
Just like you put code comments in a program.
Yep. In the Juniper world, you have a wonderful way to do comments,
Yeah.
but unfortunately, the Cisco world, and that's why I said in the Cisco world, you saw in my examples of configuration tabs, I put a description tag. So, and you can stack multiple descriptions in a route map, which is kind of cool. So if you really want a long essay about what you did, I guess you could do that and reference your ticket number. Typically, we'll put in a few-word description to reference the ticket number and go back to the ticket if you need history type of thing. But if anybody is curious about really large-scale automated systems, the Internet guys and it's Miro now, right? Yeah. The Miro stuff does a lot of automated-based stuff and on their own backbone, but it's way out of the scope of what we're talking about here. Yeah. Any other questions or comments? No? Okay then. You got one? Come on up. We have to. I zoomed through this last time.
I have
it took me
6
85
questions,
minutes,
but it's I don't want to be taking people's time. What is it
have-
supposed to end?
We have 15 minutes to kill.
15 minutes, okay. So I have some colleagues who do this sort of thing. Basically, it's their full-time job.
Yeah.
How often does somebody in your client base have to do this?
With this system, such minimal tuning, we can go months without touching it. If traffic patterns shift, so if we significantly increase the amount of traffic we're pushing, the thing about it is, it grows. Once you have it set up, if your internal traffic grows, the utilization pretty much grows proportionally. Usually, when there's a change, is if you've made a physical change where maybe you've increased your link to one of your ISPs, or you've made a contractual change, you've increased your command or reduced a rate, or if there's been a significant change on a third-party network. Maybe an ISP has merged with another ISP and they've collapsed ASNs, or a large broadband provider just shifted a lot of their eyeballs from one ASN. This is stuff we've seen the past few years, obviously, where a large broadband provider shift traffic to another major ASN. But if things remain pretty stable and your traffic is growing at a steady rate, we've definitely gone a couple months without even touching it. Yeah, and actually, my old stomping grounds, they went a couple of years without touching it. I set this up when I was working for Sony Online, and then I came back in 2 years later to answer some questions, and they hadn't even made a single change on the metrics that I'd set up for 2 years. That was from the period 2005 to 2007. Just stayed steady.
I'll just speed up through my questions. The third one was about basically if you're making these transitions, it seems like at the time where you're doing it at peak time, it seems like it's quite likely that they would be suffering performance issues. Without naming names, has everything gone okay in that transition time?
Like at the moment you make the transition?
At the moment that because you're doing all this experimentation, right?
Right.
Even in that very simple example, you had 100, 200, 300, 300, 200, 100, 100, 200, 300. And you can imagine if you have something slightly larger, it could take a hit.
No, so if you do it slowly, you do it softly and slowly and gradually. Now, the very first time you might cause a hit, but if you've done it a couple times, you do it slowly. You make a change, clear soft in, you wait anywhere from 3 minutes to 20 minutes, depending on if you're running a network that Richard happens to be working on or a smaller size network. You give it some time, you clear one session at a time. It's fairly safe. Truth be told, there is a chance, depending on your network, that for a brief period of time, you might actually have routing loops. A brief period of time might be a portion of a second up to 5 seconds, where two routers are still deciding on the best path and they each think each other's the best path, so they send packets back and forth. That happens. It definitely happens. It usually is inconsequential, though. Meaning if you have a lot of state-based, here's what I've seen. Using a lot of state-based traffic, so I'm doing 4 gigabit per second on this link, and I make a change, I don't have a drop to 0 and a link back up. I don't lose a whole bunch of customers. So at Sony Online, I can name them because I was an employee there and I feel comfortable with that. So we were doing UDP-based games, EverQuest, PlanetSide, Star Wars Galaxies, and we had a very aggressive. It was all UDP-based, so we weren't relying upon TCP, keep alives and kernel-based retransmits. And we had a very aggressive UDP-based keep alive scheme because there was a concept of fairness in the game. If a client disconnects from the network, the server should detect that very, very rapidly. Otherwise, you might have a player who can't react to something, and there's a monster bashing on him, and he's not clicking back, lightning bolt, and he's getting killed unfairly. So we would disconnect users anywhere as early as 2 seconds, all the way up to, as you increase the duration from 2 to 30 seconds, there was an exponentially greater chance that we would detect the disconnect. So usually between 2 to 10 seconds, we would catch almost everybody. Within 30, guaranteed they're gone. But we can do this change, and we'd have less than 2 seconds of impact, so we would never see a player count drop. That was our key metric at Sony, was how many players are online right now. And if there's ever more than 2,000 simultaneous drop, it raised an alarm, and one of us got woken up. So we were able to do this quite a few times without causing player count drops. In the large streaming world, which is where you're seeing the other high bandwidth players right now, it's all TCP based, and hopefully it's all buffered, so maybe 2-3 seconds of packet loss might not impact you. But in general, those are worst case scenarios. It's very rare, especially with some of the smaller content networks. We're talking about maybe 4 border routers and maybe 4 core routers in one regional area. And look, if you have 75 routers across the country, you want to do a little bit more than this anyway. Yeah, it doesn't really apply to you.
Part of the reason I'm asking all these is anyone who was around 5 years ago, remember Route Science and the whole bunch of folks would come here and talk about load balancing with an automated tool. And they were saying, look, you have to be doing these things on a minute-by-minute basis because you're never sure what's happening on the other side, and the performance is degrading. So they're saying this is something that you have to do all the time. And heck, you're going to have to spend money on getting various flow tools and this and that. You just buy this box; it'll take care of it. You don't have to do this experimentation. There's all sorts of things you just took care of all by itself.
Yeah.
And, a few 100,000 euro there is really not a big deal necessarily on the grand scheme of things. So assuming that money is not a problem, were they just wrong that this is not, that the problem exists clearly, but the problem does not require that kind of a solution, but something more like this?
So the Route Science and the FCP, NetVMG now, Internet FCP guys, they aren't making shifts. So shifting in this way, if you have a catch-all shift, for example, you're shifting 280,000 routes. The Route Science FCP guys are shifting maybe 1 route at a time. So the impact is much less severe. They're in many cases they're injecting a /24 or /22, and I don't know, maybe they're doing 1 per minute, 1 per 10 minutes. So it's not going to have as much impact. They're not making 280,000 routes at one time. Obviously, the FCP can't even keep track of that many. I don't want to represent the number, but it's nowhere near 280,000. But you wouldn't want to anyway. But so the route optimization boxes, and then there's a Cisco OER. If anyone's using OER, anyone at all using Cisco optimized edge routing? Okay. I really wish somebody could tell me about it in the real world. Not a dig on Cisco. I think the white paper is great. I just want to hear what other people have experienced. So those products are neat. They have a lot of requirements that your network has to meet in order for them to be truly effective. But if you meet them and you're willing to pay for it, they actually do a pretty decent job. But if you don't have the budget, this is free. Well, this is not free. This takes engineering time, but it takes nowhere near what the cost of one of those boxes would be.
Because, you know, man hours are always free.
Say again?
Man hours are always free if they're on salary.
Man hours are. But if you're contracting, which again we are contractors, then you're paying real money for it.
Right.
But definitely less than it would cost for an appliance.
Okay. Just want to talk about the whole issue of how many routes get moved at a time. And really, I mean, to speak on our systems, the FCP and Miro, we only pay attention to routes that we see a significant amount of traffic through our flow analysis. And typically, over the course of a 24-hour period, that's maybe 30–40% of the global route table, tops.
Yep. Yeah. That's a really good point.
Yeah.
If you can do that, and you're keeping, that's why I said there are requirements where you're either looking at flow data or you're doing promiscuous sniffing, passive flow analysis where you're sniffing traffic. You don't need to shift 4.7.0.0 if there's no traffic from a network going to 4.7.0.0. Right. In the metric system, you're just shifting everything without any knowledge of whether or not it's going to have an impact.
Yeah, and that's in our service point, which is multiple customers. So if you're talking about a single installation, a single customer, the number of routes you're actually sending traffic to is probably going to be far less than that.
Absolutely. Yep. Absolutely. Yeah, the optimization systems definitely have some value. They do work in some environments, not all environments, and they have increased costs.
So one point I want to make about what you were talking about, taking it slow, doing the traffic changes and shifts and seeing what balances where. A lot of people, especially content people, don't understand the impact that they make to their providers. Yep. So when a content customer who might have 50 gigs of porn all of a sudden starts playing with a route map and moves 5 gigs to 701 capacity that didn't exist before, that could really impact their providers. So you want to be careful with doing AS matches, specifically for that reason, where you move a huge chunk of traffic that didn't used to exist that now does exist, and maybe you move it back 15 minutes later. And it's the kind of thing where your upstream, if you told them about it, or if they were planning for it, or even if you just left it that way, they might notice, oh, this is a problem, and rebalance some of their traffic. But if you just do it for 15 minutes at a time, it can be a real problem. So people should keep that in mind.
So it's a good point. So in the example I gave with the 10 gig for that one area, we actually had an open line of communication to the 3 ISPs. We learned a lot about their network through open communication, where their pain points are, where their good points are, where they have extra capacity, where they're planning on capacity, and we also gave them heads up about changes that we're making. Where I cover in the slide, I'm saying you want your network, your BGP engineers to be involved in the routing communities, and the network organizations such as NANOG or RIPE or Aaron, and that's for general information. But absolutely correct. If you can speak to your ISPs and understand what they're doing, and have them willing to tell you what's going on, what the impact is, and the shift you made, that's a really good point. Also, another good reason, I'll add that next if I do the talk again, I'll add that as reasons to not do per ASN tweaks. If you're really making decisions based on communities, based on AS hop length, you'll find it has usually less of an impact to your ISP, or it gives them the opportunity to make secondary shifts if they have to. Absolutely, that's great. Okay, anything else, guys? We are at 5 more minutes. That means you get out 5 minutes early. Thank you very much. Peak Web Consulting, if you do have additional questions, if you find that you need work done, if you want somebody to come into your organization and help you either by doing training or implementation, stuff like that, my email address is obfuscated at the bottom, but I'm sure you could figure it out. I'm happy to assist with casual questions or, of course, even business engagement. So thank you very much for your time.